Okay, so this is team number 3's NASA Mars rover final report. This is our overview. Introductions. We are team number 3. FJMP Technologies. Our company encompasses Luke Farnes, manufacturing lead number 1. Nico Jensen, software engineer number 2. Lance McMahon, software engineer number 1 and test engineer. And Justin Purrier, who is our manufacturing lead number 2 and project manager. Background request for proposals, RFP. So this RFP was provided by NASA. This RFP basically describes our tasks for the report. The phase 1 summary customer requirements document. The NASA Mars rover shall gather scientific data on the surface of Mars. It must travel on the surface of Mars by navigating terrain, avoiding obstacles, and following commands. And it must achieve line tracking, obstacle avoidance, and Bluetooth control.
So here's phase 2 of our manufacturing activity. Our team came up with a list of changes and deviations from the assembly instructions. So our team followed the instructions very carefully, step by step. We all split up the task of putting together the major parts, such as the main chassis and the ultrasonic sensor module. But one problem our group had was assembling together the rover with incredibly small screws and hardware, which made it difficult to hold on to and screw in. But once our team split up the task and everyone had their own set of instructions, the team worked very effectively and quickly. The other problem that arose with the actual assembly was a small mistake of putting the line tracking module upside down at first, but it was quickly recognized and fixed. So our team came up with some recommended changes to the assembly instructions. We believe several adjustments should be made to the instructions to better show each step on the rover and to show the exact piece used. All the pieces could have been each numbered and separated so it's clear what screws and bolts used on each part. There should also be improvements made to the pictures used throughout the instructions. They weren't very clear, which proved difficult to see exactly which direction each piece had to be placed and caused the line tracking module to be put on backwards at first.
Okay, so this is our DD250, which is a verification readiness inspection. So for the upper chassis, lower chassis, and mated chassis of our rover, it was all above board. We got the maximum amount of points, 60 out of 60. This is our DD250 test results. For the line tracking demonstration, we were not able to complete that due to a faulty sensor on our rover. But other than that, the obstacle avoidance demonstration, the Bluetooth control demonstration, and the software development demonstration were all completed and approved.
So here's the line tracking test video. So you can kind of see how our rover was reacting with its sensor and how it wasn't following the correct commands that the software had told it to. So as you can see in the video, the rover just wasn't following the black lines that were on the whiteboard for its line tracking test. It was just going straight forward without like trying to stop and sense the line. And the rover was just, the sensor was malfunctioning. It was just proved to be defective afterwards. So for the line tracking test results, what went right? So when it comes to the assembly of the rover and the uploading of all the software, like in the correct order, the team followed every single step correctly. What went wrong or what could have been better? So while troubleshooting took place, trying to fix the code, trying to change sensitivity of the sensor, the line tracking device still proved to be defective. If the line tracking device was working properly, the test would have gone smoothly since we already had uploaded the software and taking other steps, like I said, like changing the sensitivity and making sure it wasn't backward, going over the assembly instructions. So if the tracking device was working, every single step would have gone smoothly. And due to a few errors in the assembly process, as well as like uploading process with like software, the team did end up having to take time to test the rover after the scheduled class time. So for the obstacle avoidance test results, what went right? The rover had avoided all the objects in its way that were provided, such as like human legs and walls, and the rover was also able to avoid and reroute from all these obstacles that were given. So what went wrong or what could have been better? If the sensor was stronger, if it was able to pick up bigger objects, the rover would have been able to avoid these smaller objects such as chair legs, but they were not detectable by the sensor. And the rover had like barely hit a trash can while it was trying to avoid a wall. But this was at fault because of the sensor, and the strength was not strong enough to pick up both the trash can and the wall, but it had focused rather on the wall and had not picked up the trash can in its way. So it chose to avoid the wall rather than the trash can.
So what went right? The rover was ultimately able to respond to every Bluetooth command in the desirable manner, and we were able to demonstrate this through the testing. And this could be seen in the DD250 test PDF as we were checked off for the Bluetooth test. So what went wrong and what could have gone better? So at first, the software engineers didn't realize that the order of uploading the files was crucial to the rover functioning properly. So this resulted in a delay in being able to test the rover. But after we realized that we needed to upload the files in a certain order, we were able to quickly fix this issue by simply uploading the files in the proper order, and then we were able to run the tests. So for the rework and redesign activity, what files were uploaded to the rover and why? So firstly, we uploaded the file AutoGo to ensure that the hardware on the rover was functioning correctly. And the second file we uploaded was Bluetooth car. And this file essentially established a connection between the controller app on our phone and the rover. So the third file we uploaded was called line tracking car. And what this file did was give the rover line tracking capabilities. However, we weren't able to see this in the tests because our line tracking sensor was defective. So what problems or challenges resulted in adjustments to the software? So as stated before, the order of uploading the files is crucial for the rover to function properly. And we didn't realize this at first. So the rover was virtually unresponsive, completely unresponsive to any command we would send at it. But once we realized that we need to upload the files in a certain order, we proceeded to upload them in the specified order, and we recovered quickly from the error, and we were then able to test the rover. And it did function properly for all the files uploaded, but we were not able to see the line tracking because we presumed that the sensor was faulty.
So conclusions, comments, and takeaways. What did we accomplish? So for the assembly, the ultrasonic sensor was initially oriented facing the wrong direction by 180 degrees. The team was able to fix this, and the assembly of the rover was ultimately completed exactly as specified. For the test, all test results went as planned, with the exception of the line tracking functionality of the rover due to a faulty sensor. The rework/redesign, as a result of the team uploading the software incorrectly, going back and re-uploading the software in the correct order was required. In an attempt to fix the line tracking sensor, we tried to use a screwdriver to rotate the sensitivity swivel, but this proved unsuccessful, which meant that the line tracking device was defective.